We've been working on expressions and factorising expressions. Today what we're going to do is extend that up to solving quadratic equations. And the technique we're going to learn today is called the Null Factor Law. Okay, so all the factorising you've been doing is leading up to today. So an exciting turn of events. What is this? X squared plus 7x plus 10. Girls, if you remember back to year 7, that's called an expression. What's this? It's got an equal sign in it. This is what we call an equation. What's the difference between them? Well, an expression is just that. It's an expression. It is a collection of terms stuck together. Doesn't really do a lot. Okay, an equation is totally different though. It's a relationship. Okay, it's a relationship between y and x. In essence, if you feed an equation a value, it can work out the corresponding value of y or x depending on what you give it. So x squared plus 7x plus 10 is not a relationship. It cannot be graphed. Y equals x squared plus 7x plus 10 is a relationship and it can be graphed. And actually the graph of it appears to the right. That's what a parabola looks like. That's the first one we've seen so far. All right, let's see how that works. So I'm noting here that when x is -2, the y value seems to be 0. Let's try that out on this particular equation. So our equation is y equals x squared plus 7x plus 10. Remember what an equation does? It says basically, give me a value of x and I'll tell you what y is at that point. So I'm expecting, girls, that if I give it -2, it should tell me if this relationship, this is the picture of this relationship, it should tell me that the y value is 0. So let's just try it out. So we're going to go -2 all squared. Don't forget those brackets there, really important. +7 times -2 is -14 plus 10. We got y equals -2 squared is 4. Take 14 plus 10. Y is equal to 0. So this is suggesting that when x is -2, the y value is 0. And all of these other points on this parabola here will, if I substitute these x values in, will produce those y values there. So again, that's the picture of this relationship. All right, now this seems a little abrupt to go straight to this, but what are the factors of 0? Okay, so let's have a look at the factors of 0. Well, how can I make 0? 0 multiplied by 3, that equals 0. So there are two factors of 0. 0 multiplied by 10 is 0. 0 multiplied by pi is 0. 0 multiplied by the very unattractive fraction of 29 over 67. Okay, that's 0 as well. Now, what do you notice about all the factors of 0? Every one of them has 0 as one of the factors, and the other factor can be whatever it is. Now, this is unique to 0. It doesn't happen for any other number. Okay, so if you try it out, like let's go 24, which has got bucket loads of factors. All right, what we'll do is we'll go 1 times 24, 2 times 12, 3 times, what is it, 8, 4 times 6, 6 times 4, etc., etc. Notice when I'm multiplying together, the two factors are completely different. Okay, 1 and 24, 2 and 12. So this doesn't have this same thing that happens where with 0, one of the factors is always 0. Now that is really important when it comes to using this thing here, the null factor law. Okay, so here it is. If a times b equals 0, then either a equals 0 or b equals 0. Okay, so if this is the case, then this one could be 0 or this one could be 0 to make it true. So what we're going to do is use the null factor law to find the x-intercepts of a quadratic, okay? And we won't be able to apply the null factor law every time, okay? Now, why is that going to be the case? Well, if we're kind of trying to find the x-intercept, and that's our parabola there, then it doesn't intercept the x-axis. So we're going to say here that not all parabolas, whoops, I can spell, not all parabolas have an x-intercept or intercepts. Right, so here we go. Use the null factor law on y equals x squared plus 7x plus 10 to confirm that the coordinates of the x-intercepts are these, and hence label the coordinates of the x-intercepts. All right, let's do it. All right, so this is the exact same process that we would use for linear. So the x-int occurs when y equals 0. All right, so let's let y equal 0, and we're going to say 0 equals x squared plus 7x plus 10. All right, now what I need to do is work out a way to solve this. Okay, now many students get confused, take 10 over the other side, try to factor out something, and it gets a little messy. Here's the technique that we're going to use. Remember, parabolas are different from linear functions. They behave differently. They have different kind of characteristics. Therefore, you must treat them differently. So all that factorised we've been doing is now going to be used. What I'm going to do is factorise this right-hand side. 0 equals. All right, let's use the cross there and say that we've got x, 2, and 5. Both of them are positive. So it's going to be x plus 2, x plus 5. All right, now why is this a good thing? Well, according to the null factor law, this is the null factor law, if a times b equals 0, either a or b is equal to 0. And we've got that set up here. These two binomials are being multiplied. So what I need to do is say that either one or the other could be 0. So x plus 2 could be 0 for this to be true. Okay, so if this one here is equal to 0, 0 times this will be 0. In which case, x could be negative 2. Try it out. If I put negative 2 in here, that becomes 0. 0 times this equals 0. So that's one possible solution. Now, another possible solution is this one could be 0. So x plus 5 could be 0. In which case, x is equal to negative 5, just solving algebraically. Okay, I'm just subtracting 5 from both sides. So I've got x is equal to negative 2 or x is equal to negative 5. Will both make this true. Both of these scenarios will make it true. All right, so what have I done? I've found out the x-intercepts here. So the x-intercepts, when y is equal to 0, x is equal to negative 2. So when x is negative 2, y is 0. When x is negative 5, y is 0. Let's go back to the question and see what I was supposed to do. Use the null factor law. Yep, I've used it. That's where I've used it. On this equation to confirm that the x-intercepts are negative 5, 0, there it is, and negative 2, 0, yep, there it is, and hence label the coordinates of the x-intercepts. All right, so over here we've got negative 5, 0, and over here we've got negative 2, 0, okay? So the only way to do this with parabolas is to factorise so that we can set up the null factor law. There's no other way to do this particular problem. And that's why factorising has been such an important step for you to learn, is that we need to apply that to parabolas that are written as trinomials, or that are trinomials. All right, let's try it with this one here. So this one, find the x-intercepts of the following, if they exist, and the y-intercept. Label these points and the equation of the axis of symmetry where appropriate on the graph. We're going to worry about the axis of symmetry a little bit later. Well, no, actually, let's do it. Okay, so let's start this up. So the first thing I'm going to get is the x-intercepts. Now, when do x-intercepts occur? We're going to say that x-int when y equals 0. We're going to go 0 equals x squared, take 9. All right, so now what I'm going to do is one of two things. Okay, so this is where quadratics get a little bit tricky because there's so many different ways to do things. All right, this one here, I'm going to solve both ways. All right, so the first method I'm going to note is I've got two terms here being subtracted. I believe that this is a good situation for dots. 0 equals x squared take 3 squared. 0 equals x take 3, x plus 3. All right, we're ready to go with the null factor law. Either this or this could be 0, in which case, if that is equal to 0, x is equal to 3. And if this is equal to 0, x is equal to negative 3, which looks nice and symmetrical there on the graph. Okay, so we're going to label our x-intercepts. This one here is 3, 0. This one here is negative 3, 0. All right, what else? Let's do it another way. Okay, so the other way to do it is to go 0 equals x squared take 9. Okay, so this is the same line. Now I'm going to do something a little bit differently. Okay, so with this one here, it's not a trinomial, so we can treat this a little bit different. I'm going to add 9 to both sides and say 9 is equal to x squared. Now to solve for x, what I'm going to do is take the root of both sides. That means that x is equal to, now remember, when we're doing this, there's two possible answers. It's plus or minus 3. Now, why two possible answers? All right, well, let's try and put it in there and see what happens. If I put negative 3 into this, negative 3 squared is 9. 9 take 9 is 0. That meets the requirements. If I put in positive 3, that's 9. 9 take 9 is equal to 0. So when I do this particular move here, x squared equals 9 and root both sides, I need to consider that the answer could be plus or minus 3. All right, now we want what they call the y-intercept. So let's do the y-int when x is equal to 0. Okay, so y is equal to 0 squared take 9. So y is equal to negative 9. So when x is equal to 0, the y value is negative 9. All right, what is the axis of symmetry? The axis of symmetry is a line about which, and this is supposed to be, I'm just going to try this again because it's supposed to be on that line. Okay, so let's try that again and get it actually on there. So it's drawn as a dotted line, okay, and that line there actually has the equation x is equal to 0. Okay, so that line there is called the axis of symmetry. It's the line about which the parabola is symmetrical, okay, or kind of like the middle of the parabola, if you want to call it that. All right, let's go on to the next one. All right, now it looks like this one here is going to have only one x-intercept, okay? All right, let's find out what the algebra does. So we're going to go x int y equals 0. So let's do it. 0 equals 9x squared, take 42x plus 49. All right, now I know something that's going to happen where this is the case is I'm going to get a perfect square when I factorize this, okay, because I know that that will produce only one solution. Let's just see what happens when I use the cross to factorize. I'm going to go 7, 7, 3x, 3x, and this one is going to be negative and this one's going to be negative. All right, now let's just check it out. I've got negative 21 and negative 21, which when added together equals negative 42. Definitely got a winner there. 3x takes 7, 3x takes 7. All right, so let's use the null factor law. Okay, either this or this could be equal to 0 to make this true. All right, so I've got 3x takes 7 equals 0, in which case x is equal to 7 on 3. All right, so that's one of the x-intercepts there. Let's do it for this one here. 3x takes 7 equals 0, x is equal to 7 on 3, the same one, okay? So that move didn't need to be made, I just did it to kind of make a point here that we get the same x-intercept. There's one x-intercept, and that sort of suits the picture over here on the right-hand side. All right, so here's our x-intercept, okay? 7 on 3, comma 0. All right, our y-intercept. So y int when x is equal to 0, y is equal to, this one here will be 0. When I substitute that in, that'll be 0. We're left with 49. So up here is the y-intercept, which when x is equal to 0, the y value is 49. All right, the axis of symmetry is along this line here. And that will be along the line x is equal to 7 on 3. Okay. Let's try this one here. So what we want to do is find the x-intercepts of this parabola, okay? And it doesn't seem like they have any. So we can see that this parabola doesn't have any. But look, stuff it. The kind of maverick that I am, I'm going to get algebra to force out some x-intercepts. Let's see what happens. Okay, x int y equals 0. 0 equals x squared plus 9. X squared equals negative 9. What I'm going to do is square root both sides. X is equal to plus or minus the negative root of 9. Now, what's wrong with that? Well, the first thing is, what's the definition of square root? Okay, it's the number when multiplied by itself equals the number underneath the square root sign. And the issue is here that every time you square a number, the result is guaranteed to be positive, i.e. you're never going to be able to square a number to make negative 9. So in this case, what we're going to say mathematically is in the real number system, this is not appropriate. You cannot square a negative number. Okay, so we're going to note in the real number system, you cannot square root a negative number. So in this case here, what it's not going to do, it's not going to let us do this, in which case, what is the algebra telling us? The algebra is telling us, therefore, we're going to say no X-intercepts. Okay, so when we're trying to square root a negative number with quadratics, basically what the algebra is telling us is please do not proceed, this is not going to happen. Right, it's time we tried to do this on the calculator as well. So again, to prove a point, what I'm going to do is ask the calculator to solve it for me. All right, so x squared plus 9 equals 0 for x, and it says there's no solutions, i.e. it's never going to be, the y value is never going to be 0. Let's try something else. So some students, every year in class, I would ask the students to do this on their calculator, and most people would say no solution, and 1 or 2 students would say, I've got something. Okay, now invariably what had happened to those students is that their calculator had gone into CPLX mode. That's called complex mode. Okay, and what's happened here? It has given us solutions. Okay, so we don't enter or pursue this in year 10 this year, but in year 11 there's a subject called specialist maths. And what they do is they envisage a situation where you could square root a negative number. Okay, and the answers to this and to further proceed is what they say is we're going to invent a new system called the imaginary number system or the complex number system to, I don't know, further engage in the problem. Okay, so if you did get an answer for that, or you do see these i's at any point, okay, square root of -1 is I, an imaginary number, then what we're going to note is that you're probably got your calculator in the wrong mode. So drop it into the real number system, re-ask the question, and it should say no solution. All right, we can get the y-intercept. It occurs when x is equal to 0. So y is equal to 0 squared is 0, that's 9. So it's when x is 0, y is 9. And the axis of symmetry is along this line here, which is the line x is equal to 0. All right, this certainly does have x-intercepts. Okay, so let's try this one out. 0 equals 7 take x squared. Now, 2 ways of doing the problem. Let's factorize it. We're going to write this as root 7 squared take x squared, which is root 7 take x root 7 plus x. All right, let's apply the null factor law. We've got root 7 take x equals 0, negative x equals negative root 7, x equals root 7. All right, our other possible one is root 7 plus x equals 0, x is equal to negative root 7. Okay, so there are our 2 x-intercepts. So it doesn't always have to be perfectly lovely integers. Your x-intercepts can be something rather ugly or irrational. Okay, so this is root 7 comma 0. This is negative root 7 comma 0. Okay, what's our y-intercept? It occurs when x is equal to 0. 0 squared is 0. The y-intercept is 7. When x is 0, y is 7. Axis of symmetry, once again, down the y-axis. Okay, a few more to go. 16x plus 6x takes 7. 16x squared plus 6x take 7. All right, so let's do this one here. So again, let's follow the basic rules. 0 equals 16x squared plus 6x take 7. All right, so now we need to attempt to factorise on this trinomial. What are we going to do with trinomials? We attempt the cross method, okay? I remember this one. This one came up on a Year 12 exam. Students had to do a whole heap of other stuff before they got to this point here, and then they had to factorise this. And this was the one that particular year students who used the grouping method could not factorise this trinomial. All right, let's try it out and see if I can get it out fairly quickly. So I think that's 2x and 8x, 8, 14. Yeah, I think I've got it. Okay, so this one here is going to be 8x and 14x. 14 take 8 is 6. This is going to be negative. Let's do the test. We've got 14x, negative 8x. When added together, that will equal 6x. Yes, winner. 0 equals 8x plus 7, 2x take 1. All right, let's use the null factor law. That says that all right, so there's our first x-intercept. When x is equal to negative 7 on 8, the y value is 0. And this is our other one. All right, so which one's which? Well, obviously this one has to be the half, 0. And this one over here will be negative 7 on 8, 0. All right, our y-intercept, if we look at it, we can just sub in 0, which will be 0 plus 0 takes 7. Our y-intercept is negative 7 when x is equal to 0. All right, we're not going to worry about the axis of symmetry at this point here. Let's just leave that one till later. So we're just going to note no axis of sym just yet. If you can think of a way to get it, that would be good. It has something to do with the x-intercepts for those of you sort of thinking about it. Symmetrical. Okay, I'll leave that with you. All right, this one here, let's get these x-intercepts. Okay, a couple of different ways of doing this. Let's go 0 equals x plus 1 squared take 16. So the x-intercepts occur when y is equal to 0. All right, so here is one particular method. I'm going to set this up with DOPS. X plus 1 all squared take 4 squared. 0 equals x plus 1 take 4. X plus 1 plus 4. Okay, 0 equals x take 3, x plus 5. Let's apply the null factor law. X take 3 equals 0, x is equal to 3. X plus 5 equals 0, x is equal to negative 5. All right, what other way could I do that one, I hear you ask? 0 equals x plus 1 squared take 16. Add 16 to both sides. Root both sides. So we're going to root that and root that. And that gives us x plus 1 equals plus or minus 4. Okay, now we're going to add 1 to both plus 4, which is x is equal to 5. We're going to subtract 1 from, subtract 1 from 4. That gives us 3, my bad. And subtract 1 from negative 4. That gives me negative 5. Notice that the two solutions we got are exactly the same. All right, let's pop some labels in there. We've got 3, 0 and negative 5, 0. All right, what's our y-intercept? So let's chuck in 0. 0 plus 1 is 1. 1 squared is 1. 1 take away 16 is negative 15. So when x is 0, y is negative 15. Once again, we're not going to worry about the x-intercept, the axis of symmetry rather. So no axis of sym yet. Okay, so two further and more difficult problems here. we want to solve these ones here. Solve the following quadratic equations for x. All right, well, when we solve a quadratic, the idea is that we have it in ax squared plus bx plus c equals 0 form. So we want the trinomial over on the left or the right-hand side and the other side to equal 0. So for this one here, what I'm going to do is expand that. 4 times 15 is 60. All right, now what I'm going to do is subtract both of these terms from the left-hand side, from the right-hand side rather. X squared take 4x take 60 equals 0. All right, now we've got it in the right form. Okay, so how do we do this? We've got a 3-term or a trinomial. So what I do is I attempt to factorize using the cross. X. All right, so it's 6 times 10. Okay, so that we're going to put 6 and 10 there. Now, one of them has to be negative, and it's going to be this one here. Let's do the test. 6x negative 10x added together equals negative 4x, which is the middle term. X plus 6, x take 10 equals 0. Null factor law, x plus 6 equals 0. X is equal to negative 6. Once you get the hang of it, you don't have to write this particular step here. X take 10 equals 0. X is equal to 10. All right, this is a pretty high-end one here. Comes up in Year 11, Year 12 methods all the time. All right, so what we want to do is solve this quadratic. And I hear you say, what? Quadratic? Where's the squared term? Well, here it goes. What I'm going to do is multiply both sides by x to knock out x from the denominator. All right, so I'm going to go x plus 6, and this side here, because it's got x multiplied by it, they just cancel out. And x multiplied by x will leave us with x squared. All right, so there's our trinomial in its basic form. I'm going to now subtract x and 6 from the left-hand side to leave us with x squared, take x, take 6. All right, cross method factorize, x, 2 and 3, and this is the negative. 0 equals x plus 2, x take 3, x plus 2 equals 0, in which case x is negative 2, or x take 3 equals 0, in which case x is equal to 3. All right, there we go. So there are the solutions to those problems. All right, so lots of problems there. Yeah, do lots and lots of practice of this, girls, to get really good at this technique.